Hello good people, I would like to talk about the anti-Markovnikov addition. In a Markovnikov addition, the halogen of the hydrogen halide, HX, written here, ends up on the more substituted carbon of the double bond. In an anti-Markovnikov addition, the halogen ends up on the less substituted carbon of the carbon double bond. So in this particular case, this carbon is less substituted and the halogen will end up on it. Why is that? Well, it has to do with the peroxides. So firstly, we need to look at what is it that they do in our reaction mechanism. So let's have a look. So here I have hydrogen peroxide that gives me two hydroxide radicals. How does that happen? Well, if I draw it out a little bit better, we can see what happens to the electron distribution. So the electrons of this bond, the bond between the oxygens, split. One electron ends up here and another electron ends up there. As a result, we have two hydroxide radicals. A hydroxide radical then can react with the hydrogen of the hydrogen chloride. And as a result, we end up with water and this chloride radical, which plays an important part in the next step in our reaction with our alkene. So let's see what happens. So once again, we have 2-methylpropene, and now it is going to react with this chloride radical. So what will happen? Pardon me. The pi electrons of the double bond will play a role. So one of these electrons will react with the radical, and the other will end up on a carbon. And as a result, we will have something like this. The chloride ends up on carbon number 1, whereas carbon number 2 is now a radical. It has a spare electron. This compound is now free to react with another hydrogen chloride. So what happens? The radical reacts with the hydrogen, and one of the electrons of the hydrogen chloride bond ends up on the chloride. And so we get our product where the halogen, the chloride, is on carbon number 1 and the hydrogen is on carbon number 2. And we also end up with another chloride radical. So this chloride radical now can react with another mole of our starting compound and repeat the whole process again. Now you might ask, why is it that the radical ends up on carbon number 2 and not on carbon number 1? Well, let's look at what happens. So I'm going to erase these arrows and redraw them a little bit differently. So now we're going to say that one of the pi electrons will end up on carbon number 1, and as before, the second electron of the pi double bond will react with the radical. As a result, we'll get this compound down here. So carbon number 1 will now carry the radical, and carbon number 2 will have reacted with the chloride radical. So why is it that the reaction doesn't follow this pathway down here? Well, it is kind of similar to our carbocation situation in a Markovnikov addition. This is a primary radical. So the carbon carrying the radical is attached to only one more carbon. Over here, we have a tertiary radical. The carbon carrying the radical is attached to 3 more carbons. And this one is more stable. And because it is more stable, the reaction pathway will tend towards the side that produces the more stable radical. In this particular case, that is the tertiary radical. And so we will end up with an anti-Markovnikov addition, where the halogen ends up to the less substituted carbon of that carbon double bond, and the hydrogen ends up on the more substituted carbon of the carbon double bond. That is all for now, and I will see you on the flip side.